All right, so we are here to talk about populations and how they are described. And so when we describe a population, there are three things we're going to look at. Size, so literally how many kangaroos are in that population, how many warthogs are in that population, whatever. The number, density, so how dense are they populated? Is it, 2 kangaroos per square mile, or is it 3,000 kangaroos per square mile, right? Not dense versus dense. And then dispersion, how are they scattered out in their environment? And so when we talk about dispersion, there's three main ways. There's clumped. This would be like a flock of birds, a herd of cows, a school of fish. Those are all clumped. Uniform. This is where they kind of space themselves out evenly. It allows for them to each have their own kind of access to resources, so it decreases competition. And then random, either where they don't care or they don't have control over where they land, or I say land, where they end up living. And so some of them might be close together, sometimes they're far apart, but it's completely random. So that's how dispersal goes. When we're looking at organisms, we can look at something called a survivorship curve. And a survivorship curve looks at a cohort of organisms. So all of the giraffes born in, 1990. I don't know how long giraffes live, but that sounds like a good number to me. And we look at if a giraffe's lifespan is 50 years. Again, I have no idea. Then this 100% would be that 50-year mark. And so at 25 years, or 50% of their life, how many giraffes are still around? And so giraffes actually would be one of these number ones as well. So you see very few deaths in the younger ages, and then as they get older, you see more and more deaths. We are very familiar with survivorship curve type 1 because that's what we see with humans. Very few deaths until middle to late ages, like 60, 70, 80, and then we see a lot of deaths. Survivorship type 2, the fact that this line is a straight line tells you that there is an equal chance of dying at any point. So the slope is negative, and so probably a -1. I'm not going to do the math in my head right now, but and that just simply indicates that you have an equal chance of dying as a teenager, as kind of an adult, midlife to the end of your life, any chance. And then you have survivorship type 3, and these are the ones that you see very little prenatal care or even postnatal care, I guess is a better word of saying it, better way of saying it. Basically, they lay their eggs and then they fly away or swim away and never go back. They don't take care of their babies, but since they're not taking care of them, they have tons and tons of babies to ensure that some of them survive. So we only have a few and take really good care of them to try to get them to adulthood. They don't take good care of them at all, but they have a bunch, like 1 million, and hope that some of them make it to adulthood. So you see lots of death early on, a lot of eggs get eaten, those kinds of things. Think of like fish eggs, frog eggs. So a lot of them don't even make it to the first quarter of their life, and then there's very little death afterwards because there's very little percentage left. So those are the three survivorship curves. And then I can calculate a change in population size when given the number of births and the number of deaths. So let's look at that. So here we have a population. We've been given, and this can be whatever you want it to be, whatever animal or plant. This could be rose bushes. And we had 14 new rose bushes be born this year, and 8 died. And so the change in population over time, so remember delta means change. Sometimes you'll see that written dn over dt because not everybody has access to that delta sign, would be big B minus big D. So 14 minus 8, which is 6. So the change in population is 6 rose bushes, and it's positive, so we know that we increase the population by 6. The next one says I can calculate the population growth rate when given the per capita birth rate and the per capita death rate. All right, per capita birth rate is little b, and it is found by dividing big B by n. Per capita death rate is found by taking big D divided by n. Okay, we're going to use the same numbers from up here. So 14 divided by 49 is 0.29, and 8 divided by 49 is 0.16. Okay, so that's the first step because rate is little b minus little d. Okay, and so that would be 0.29 minus 0.16, and that would be, I should be able to do this, 0.13? Yeah, 0.13. Okay, so I should be able to do that in my head. So that's it. So that is how you are going to find the change in population, or if they want you to find rate, then you have to find your per capita birth and death rates and then calculate rate from there. Okay, so I hope that helps. If you have any questions about any of these, any of the basic population calculations, let me know. In the next video, the one about how things that limit population growth, we'll talk about exponential and logistic factors and those equations. So if you have questions about that, then you're going to want to go watch that video. All right, guys, thanks.